Hello, I'm Alan Cheswick, and welcome to your systems review of ScienceDailyNews.com. Where together we take a networked systems or complex systems perspective on some of the more fascinating studies that are coming at you at ScienceDailyNews.com. It's my goal to fit these together in one of those views and to open up your mind into different ways of understanding information. So let's go ahead and get started. First, we will check out how the 2015 water savings laws are impacting California's residents. These laws were created in response to epic droughts that significantly stressed water usage within the Golden State. The ambitious plan was to reduce 25% of water use across all of the state. An analysis was submitted to the journal Environmental Research Letters by the good folks at University of California, Davis. Besides the obvious savings of water, California's water reduction plan saved the equivalent of over 500 million metric tons of carbon dioxide release. How did that happen, you ask? It's from the energy needed to transport, treat, and heat the water. Not looked at in this study was the health effects from this carbon reduction. Too bad the carbon reduction was not from 111,000 less cars on the road. California actually does an excellent job producing energy without burning coal. It would be nice and interesting to see if there were less asthma attacks and medical-related expenses from the reduced energy use, especially when the condition of asthma costs the U.S. healthcare system about $80 billion a year. Air quality and asthma are related, just like molecules are related, via shape and function, pretty much like everything else in biology. Essentially, asthma is an allergic reaction that causes the narrowing of airways and challenges normal breathing. Again, the key word here is allergic reaction. So an allergic reaction is what? Well, remember when I said all of biology is mediated through the interactions of shape and function? Well, let's explore that briefly. Why this happens is because living things compute with molecules. And how living things expanded and diversified over the past million years means that there's going to be some overlap of computation. So one of the main tasks of all living creatures is to perform energy acquisition. Now, unfortunately, there's not unlimited resources on Earth, and so there's competition for getting energies and resources. This competition has led some species into a niche space of attacking a host. As species have diversified, their need to identify themselves from invaders has become more important. So this is done with molecular handshakes. These molecular handshakes analyze the shape of molecules and compare it to databases. This 24/7 job, kind of like the sun, it's basically always on. Essentially, the immune system shakes hands with all the molecules it encounters. And if the object in question is shaped correctly, there's no worries. But if it has a bad shape, i.e. something that was associated with being under foreign attack in the past, it is dealt with via some very nasty oxidative chemical reaction. This system is far from perfect. And in a game theory payoff type sense, it's better to be a little bit overreactive than not reactive enough. Thus, humans, and some other animals, can develop allergies. Basically, the body thinks this foreign shape is harmful and should be dealt with. So the immune system ramps up its actions when it comes into contact with that shape, even if that molecule is chemically harmless. And so the development of allergic inflammation and having inflammation leading to allergies is pretty well documented. The authors of this study essentially argue that through probabilities and immune system misfunction from overuse, that certain shapes which are in themselves non-harmful to you can become allergenic-inducing molecules. Well, I hope you enjoyed our brief overview of Science Daily. You can see how these stories are connected in objective reality. You can see how some of these processes are related. Leave your comments and questions below. Bye.